Sorry, I'm having issues over here. There we go. Okay. So let's do a few review problems. Let's factor (7a squared b to the third minus 14a b to the fourth. And 3x squared is 20. Okay, so here's three factoring problems. Take a second and do those problems. On your own. Arjunik, I have it, you're here. Or you're still here on Zoom. So the three ways we've learned to factor so far are GCF, grouping, and Macy method, and that's what these three problems are.
Good. We can go to the all files and
Isaiah, that means too.
approaches.
I meant to.
Track your file.
B to the fourth.
And it's gonna update and select and basically upload file. You see these three dots. You click and upload file.
And I'm just there for attendance. I'm not even doing work.
And basically upload it. Once you have uploaded the file,
I can't.
and
I wish.
see this.
I actually can't. How's the laptop gonna work?
Right, so this is Excel file.
Yeah. Yeah, are you gonna buy some food? No, we're gonna buy to eat.
So on the first one, you should have got a GCF of 7a b to the third. So that's the most you can take out of all of them. So when I divide out the first one, I'm left with a. When I divide out the second one, I'm left with 2b. So 7a b to the third times a minus 2b. Questions about that? On number 2, if I have 2xy minus 3x minus 4y plus 6, that's a factor by grouping problem. So I put it in two groups. For the first two, I can take out an x, and left over is 2x minus 3. For the second one, I can take out a negative 2, and left over is 2y minus 3. And so I'm left with 2x minus 3 times x minus 2. And then the last one, this is what we learned last time, AC method. And I would say out of all the factoring, this is probably the one that you're going to see the most. Okay, so I'm going to give you like 30 more seconds to finish that one up if you haven't already. 2y, thank you. 2y minus 3. Oh, you're right. That should be 2y, and that should be 2y. So I took the x out. Thank you. Okay, so for that one, you're finding what A, B, and C are. My A value is 3, B is negative 19, C is 20. A times C is 3 times 20, which is 60. Factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So there's a lot of factors there. To get 19, how am I going to get 19 here? Yeah, to multiply to get positive 60, they both need to be positive or both need to be negative. You could put negatives on both of everything here. Which one's going to give me negative 19? The negative 4 and negative 15. Okay, so I take these two numbers. This is not a shortcut problem because 8 does not equal 1. So I have to take those two numbers and rewrite them in for 19x. So it's going to be 3x squared minus 4x minus 15x plus 20. Put them in two groups and factor by grouping. If you put the 15x first, that's totally fine. You're going to get the same answer, but it's going to look a little bit different before we get there. 3x squared minus 4x, they have an x in common. When I take out an x, left over is 3x minus 4. Negative 15x plus 20, they have a 5 in common, and it has to be a negative 5 because the first one's negative. So when I take out a negative 5, left over is 3x, 20 divided by negative 5 is negative 4. And so then they have 3x minus 4 in common. And left over is x minus 5. And that's your answer. Questions about that? Okay, we are going to move into the last kind of factoring today. The kind of factoring we're doing today, the first one is like for sure the easiest kind. The problem is it's so easy that you forget how to do it sometimes. So let's do that one first. It's section 5.7. And it's called the difference of two squares. Okay, so difference of two squares. The name of the problem describes how, like what kind of problem you're gonna actually do it to. So it's a difference problem. What does difference mean? Subtraction. So it's gonna be a subtraction problem of two squares. What is a perfect square? Something you take the square root of, right? So like 25, 64, 81, x squared, 1, all those things you can take the square root of it. Okay, so that's two things that you can take the square root of. So it's in the form of a squared minus b squared. So something squared minus something squared. Okay, this is what your problem looks like. This factors into your answer for this is 2 sets of parentheses. One set of parentheses has a plus sign in the middle, the other has a minus sign. It does not matter which one you write first. To find the thing that goes in the beginning of both sets of parentheses, it's the square root of the first term. So the square root of a squared is just a. The thing that goes at the end of both is the square root of the second thing. So the square root of b squared is just b. So that's your answer. A plus b, a minus b. Okay, so let's do some of these together. A problem would look like this, x squared minus 9. Okay, so I know this is a difference of 2 squares problem because it has a subtraction sign in the middle. I can take the square root of 9. I can take the square root of x squared. So my answer is 2 sets of parentheses. One has a plus sign, one has a minus sign. And then I take the square root of everything. What's the square root of x squared? X, and it's going to go at the beginning of both sets of parentheses. What's the square root of 9? 3, and it's going to go at the end of both sets of parentheses, and that's your answer. X plus 3, x minus 3. Okay, let's do some more. If I had 16y squared minus 49. This is a difference of 2 squares problem because it has a minus sign in the middle and I can take the square root of everything. My answer is 2 sets of parentheses. One has a plus sign in the middle, one has a minus sign in the middle. Again, it doesn't matter which one you put first. And then you're going to take the square root of everything. What's the square root of 16y squared? 4y. That goes at the beginning of both of them. What's the square root of 49? 7. That's going to go at the end of both of them. And that's your answer. Pretty straightforward. The problem is it's so easy that I feel like your brain doesn't put in as much work learning right now. So like at the end of class or by like Wednesday when we come back, you're gonna be like, I don't know how to do that problem, even though it's so easy to do it. It just takes practice and repetition to do it. So if I had one that looks like this, 4x squared minus 1. Two sets of parentheses, one's a plus, one's a minus. What's the square root of 4x squared? 2x. What's the square root of 1? 1. So 2x plus 1, 2x minus 1. What about if it was 81 minus x squared? Ooh, x squared. Okay, so 2 sets of parentheses, one's a plus, one's a minus. What's the square root of 81? That's what goes at the beginning of both of them, 9. And then what's the square root of x squared? X. So 9 plus x, 9 minus x. So make sure if it's kind of backwards, if the x is last and the number's first, you put that the same way in your parentheses. Okay, so that's the difference of 2 squares. Are you good with that? Okay. We're going to move on to the sum and differences cubes real fast. What if the number is prime and you can't take the square root? Would you not use this method at all? Correct. So if you had the problem x squared minus 7, it is a subtraction problem. It does have x squared that you can take the square root of. Can you take the square root of 7? No, so you just wouldn't. We would say, I think on Math Excel it says not factorable. Or prime, is that what it says? Prime. So you would pick the one that says prime. I'm not going to give you one on your test that doesn't factor. Like that's a waste of a problem, in my opinion. Also, what about if it was a problem that was x squared plus 25? It's the same thing. It's not factorable or it's prime because can I take the square root of x squared? Yes. Can I take the square root of 25? Yes. Does it have a subtraction sign in the middle? No, it's the same thing. This is prime also. Okay, so that is the difference of two squares. Has to have a minus sign in the middle, have to be able to take the square root of everything, and it's pretty straightforward. Moving on to the sum and difference of cubes. So this is there's two different formulas here. So sum and difference of cubes. What do you think is going to be different about these? Oops, sorry. How are these going to be different than the other ones? Instead of being perfect squares, now they're going to be perfect cubes. What's a perfect cube? Say again? What does it mean to be a cube? Something that's been raised to the third power, right? So let's think through real fast numbers that have been raised to the third power. What is 2 to the third power? 2 to the third power is 8, right? So like these are perfect cubes. 2 to the third power is 8. What about 3 to the third power? Yeah, 3 times 3 times 3 is 27. What about 4 to the third power? That one, 4 times 4 is 16. 16 times 4 is 64. 5 to the third power? 5 times 5 is 25. 25 times 5 is 125, right? And then I forgot, what's 1 cubed? Just 1. So these are the numbers that are your perfect cubes. Okay, so, and then the letters would be like x to the third power, right? So the formula here is if you have something cubed plus something different cubed, so that's what the problem looks like. So just a reminder, that's your problem. The answer is, this time it has a little set of parentheses and a big set of parentheses. In the little set of parentheses, it is a plus b. In the big set of parentheses, it's a squared minus ab plus b squared. Okay, so that's the sum of cubes because it had a plus sign in the middle of your problem. The difference of cubes is the same thing. Oh, and real fast, this part's the answer, right? It's the same thing, but your signs are different. So it's a minus b, a squared plus ab plus b squared. That's the answer for the difference of cubes. Okay, so this one's a little bit harder. And the reason why it's a little bit harder is because we haven't spent much time on the whole cube thing. So over here on this problem, to figure out what number goes in the parentheses, what did you do with the number given to you in the problem? Took the square root of it, right? The square root of 49 is 7. The square root of 16 is 4. It's because it gave it to you as a squared and we needed to get it back down to a and b. I have to do the same thing here, but this time I'm not taking the square root. I'm taking the cube root. Okay, so that may or may not be something you're familiar with. It's something we are going to learn in, I think it's the next thing after your first exam. So for now, we're just thinking like what number times itself 3 times gives you that number, okay? So it's given to you as a cubed and b cubed. We want to take the cube root to get back down to this 1, 2, 3, 4, 5, okay? So we're going to spend a little bit of time on this. Let's do a few problems. First problem, let's say I have x to the third power minus 64. Okay, so for this problem, it's kind of helpful sometimes to write what A and B are because it's such a long problem. It's kind of, you forget sometimes. So let's write what the cube root of these things are. What is the cube root of x cubed? Just x, right? And what's the cube root of 64? 4, kind of like we took the square root before. This time I'm thinking what times itself 3 times gives me 64, which is 4. Look how big these numbers get. They get big really fast. So like this is pretty much what the numbers you're going to be given. Sometimes they do 6 cubed, and I believe that's 216. That's off the top of my head. I might be wrong about that. Let me check that. Oh, goodness. 36 times 6. Yeah, it's 216. Sorry. Okay. So sometimes you'll have that one, but it's mainly these first 5. Okay, so is this a sum problem or a difference problem? Difference, because this is minus sign. So I'm going to use this bottom equation. So my answer needs to be a minus b, a squared plus ab plus b squared. Sorry, it's kind of all squished together. So let's put in my answers, or my a and my b. A minus b, what would that be in this problem? X minus 4. And then I need to do a squared is x squared. AB, so what's a times b? What's x times 4? 4x, and it's plus 4x. And then plus b squared. What is b squared? What is 4 squared? Yeah, 16. And that's your answer. You will be given these formulas on your exam. You don't have to memorize these formulas, but you have to know how to use them. Let's do some more. Let's do x to the 3rd power plus 8. Okay, so here, what's my a value here? What's the cube root of x cubed? Just x. What's the cube root of 8? What number times itself 3 times gives me 8? 2. Which formula am I going to use? The sum formula or the difference formula? The sum, the one on top, because it has a plus sign here in the middle. So I'm going to use the one on top. A plus b, a squared minus ab plus b squared. And when I put my information in, a plus b, that's x plus 2. A squared, what is a squared? X squared minus a times b. Yeah, x times 2 is 2x plus b squared is 4. Questions about that? Okay, let's do another one. What about if it was 125x to the 3rd minus 27y to the 3rd? So this is like as hard as it gets. What's my a value here? Yeah, a is the cube root of 125x cubed. So what number times itself 3 times gives me 125 is 5. And then the cube root of x cubed is just x. What's my b value here? 3y. Okay, this one's a little bit trickier when you're plugging it in. Is this a sum problem or a difference problem? Difference. So I'm looking at the bottom one, and the formula is a minus b, a squared plus ab plus b squared. Okay, so when I go to put it in, a minus b, what's a minus b? 5x minus 3y. A squared, you have to square the 5 and square the x. What would that be? 25x squared. Plus ab, what's 5x times 3y? 15xy, so plus 15xy. And then plus b squared, you have to square the 3 and square the y? 9y squared. Oh, And that's your answer. Questions about that? Okay, so that one's a little bit harder. Let's do this last one. You do this one while I pass out the paper we're about to use. Let's do 125a to the third plus 1. I'm not going to do a. A is confusing. Let's change that to x. It's confusing because there's an a in your answer or in your problem. So 125x cubed plus 1. Okay, so for this one, my a value is 5x. What's my b value here? 1. So when I put it in my formula, I get 5x plus 1. And then when I square a, it's going to be 25x squared minus 5x plus 1. And that's the answer. Questions at all about that? Okay, so we've learned 5 different types of factoring. GCF, grouping, AC method, the squares that we just did, difference of 2 squares, and then now the sum and difference of cubes. So one of the hardest parts about factoring is looking at a problem and saying, what kind of factoring is that? Is that AC method? Is that difference of 2 squares? Is that whatever? Because the directions don't say factor by grouping or factor using the AC method. It just says factor and gives you 10 problems or whatever. So that's what I gave you that little flow chart thing for. So we're going to kind of go over this. So if you are zooming in, this is under week 2 documents. You can pull it up or you can just watch. So this is how we factor every single problem. The whole idea of being a factoring using a GCF, that could be any problem, and it could be in an AC method, it could be in a difference of 2 squares problem, it could be in all the problems. So our first question for every factoring problem is, does it have a greatest common factor? If it does, you factor it out, okay? From there, and so I would say about 20% of the problems have a greatest common factor. Sometimes that's all it has, and you're done at that point. Sometimes you can, or most of the time, you can keep on going. So to decide what kind of problem it is from there, we look at the number of terms. If it has 4 terms, what kind of factoring is it? Grouping. That's the first thing we learned. Anything with 4 terms has a grouping, or you factor by grouping. If it has 3 terms, you factor using the AC method. And remember, we have the shortcut is when a equals 1. If it's 2 terms, it's either squares or cubes. That's what we learned today. Everything we learned today only had 2 terms. So how can I tell the difference between a squares problem and a cubes problem? An exponent can tell you, like an x squared or an x cubed. There's one other thing that can tell you. Well, they both could have minus. So what about the numbers? If it's a cube problem, what numbers do we have? 1, 8, 27, 64, 125, 216. right? All of those except for 2 of them technically are just cubes. Like, can I take the square root of 8? If you had an 8 there, you know it's not a square root problem, right? If you have a 27, you know it's not a square root problem. 64 is tricky because it's square root and cube root. So lots of times you can just look at the numbers and say, oh, that's a square root problem because I can take the square root of all that stuff, okay? So that's how you tell if it's squares or cubes. And then from there, sometimes you can keep on going. It doesn't happen very often. Every once in a while, the higher up you get in math, it happens more often. So I'll probably show you one problem like that. But that's where we're going to spend a little bit of time on now. We're going to spend about 5 minutes on this. I'm going to give you a couple problems, and we're going to kind of use this thought process to figure out which one it is. Okay, so the first problem we're going to do is 36x squared minus 9. Okay, so this is kind of a tricky problem. What is the first step for every factoring problem? Huh? Yeah, check to see if it has a GCF. Does this have a greatest common factor? Yeah, it does. It has a 3. 36 is 12 times 3. So yeah, it only has a, wait, can you do 9? It has a 9 in common too, right? 36 is 4 times 9. So I can take out, so first thing we do for every problem is check for a GCF. Okay, we do have a GCF here. It is 9, so let's take it out. When I pull out a 9, 36x squared divided by 9 is what? 4x squared. And 9 divided by 9 is 1. Now that you pulled out the greatest common factor, you just kind of keep it there till the end, and you then see how you can factor this. So now 4x squared minus 1, how can I factor that? First you look, how many terms does it have? 2 terms. So it is either squares or cubes. Which one is this one? Squares, because I can take the square root of 4, I can take the square root of 1, it has an x squared, and it has a minus sign. Okay, so let's factor that using the difference of 2 squares. The 9's still going to stay at the beginning. I need 2 sets of parentheses. One has a plus, one has a minus. And then how do I get the stuff inside? Square root everything. What's the square root of 4x squared? 2x. That goes at the beginning of the parentheses. What's the square root of 1? 1. And that's the correct answer. On this problem, if you didn't check for a GCF and you just went straight from here and did difference of 2 squares, you would get an answer that is not finished. Like from there, you would technically have to take out the GCF, and that's a lot harder. So it's easier if you take out the GCF at the very beginning. Okay, let's do another one. What about if I had the problem 2x squared minus 10x plus 12? First step, does it have a GCF? Yes, it does. What is the GCF here? 2. I can take out a 2 from everything. So let's pull out a 2. When I take out a 2, left over is x squared minus 10 divided by 2 is 5x plus 12 divided by 2 is 6. Okay, in this case, taking out the 2 actually helped us. Before, what kind of factoring problem? Before I took out the GCF, what kind of factoring problem is this? The 3 terms, which is AC method. Is this a shortcut problem at the beginning? No, when I took out the 2 now, is it a shortcut problem? Yeah, because A is 1 now. Okay, so I leave the 2 until the end. I just kind of forget about the 2. My A value now is 1. What's my B value? -5, and my C value is 6. Again, this is an AC method problem because now looking in the parentheses, I have 3 terms. So A times C is 1 times 6, which is 6. 2 things that multiply to give me 6. 1 and 6, 2 and 3. Are these both going to be positive, both negative, or one of each? Both positive or negative, right? Because it needs to multiply to give me a positive. They need to add to give me a negative, so they're both going to be negative. So 1 at -1, -6, -2, -3. Which one's going to give me -5? 2 and 3, right? Is this a shortcut problem? Yeah, so that's my answers. X minus 2, X minus 3. Don't forget to put the 2 out in front of it. X minus 2, X minus 3. Questions about that? Okay, what about if I had 8a squared b minus 4ab? What's your first step? GCF. So what is my GCF here? 4ab, right? So when I take out a 4ab, left over 8 divided by 4 is 2. A squared, when I take out an a, I have a left over. I took the b out. Minus 4ab divided by 4ab is 1. So now look inside. How many terms do you have? 2. So that's either the difference of squares or the difference of cubes. Does this seem like one of those types of problems? This is just a plain old GCF problem. Okay, does that kind of make sense? The plan for each problem? Okay, so the majority of your tests on Friday is factoring, like 3/4 of it is factoring. The rest of it is either the stuff we did at the very beginning, like X and Y intercepts, find the slope, interval notation, and I have a review. I'm gonna pass out for it. The only other thing on your exam is one more section, and I'll get it done in 5 minutes. It's pretty quick. Section 5.8. It's called solving by factoring. Okay, so we can actually solve quadratic equations, solve equations that have an x squared in them by factoring. And it's actually one of the easiest ways to solve. And you'll be doing this a whole bunch in college algebra and in this class later on. So if I had a problem, we're going to start off pretty easy. If I had x plus 2 times x minus 6, that's already factored, right? All of these problems, if we're solving, they have an equal sign. So this equals 0. The way that we solve this to figure out what x is, you set both of your parentheses equal to 0 and solve them, okay? So, sorry, we want to set both sets of parentheses equal to 0 and solve. So in this case, it's already factored for us. Sometimes we actually have to factor it first. Already factored for us. Set them both equal to 0. So x plus 2 equals 0. X minus 6 equals 0. And then solve them. So x plus 2 equals 0. How do I solve for x? Subtract 2, right, from both sides. So I get x equals 0 minus 2. It's negative 2. And that's one of your answers. On the other side, x plus 6 equals 0. I'm sorry, x minus 6 equals 0. I'm going to add 6 to both sides. And I get x equals positive 6. And those are your two answers. Okay. Sometimes you have to factor first. Let's do one of those. If I had the problem, 2x squared plus 9x minus 5 equals 0. Okay, so I don't have the parentheses here to set equal to 0. So first thing I have to do is factor it. So let's think through a factoring. First thing you do is is there a GCF? No, there's not a GCF all the way through. How many terms do I have here? 3. What kind of factoring is it? AC method. What's my A value? 2. What's my B value? 9. C value is -5. So A times C is 2 times -5, which is -10. Is this a shortcut problem? No, this is a long one. So things that give me 10, 1 and 10, 2 and 5, I need to get 9 out of that. Which set of numbers is going to give me 9? The 1 and 10, I need one of them to be negative. Which one's going to be negative? The 1, because it needs to be +9. So your bigger number needs to be positive. So I go back in, I put that in my problem. So 2x squared minus 1x plus 10x minus 5. I need to factor that by grouping. So 2 sets of parentheses. 2x squared minus 1x. What is the GCF there? X. And when I take out an x, left over is 2x minus 1. 10x minus 5, what's the GCF there? 5, positive 5. When I take out a 5, left over is 2x minus 1. So it factors into 2x minus 1 times x plus 5. And now I can solve it. How do I solve? Set each of those factors equal to 0. 2x minus 1 equals 0, and x plus 5 equals 0. So on the left-hand side, 2x minus 1 equals 0. I'm going to add 1 to both sides, and I get 2x equals 1. How do I solve for x? Divide both sides by 2, and so I get x equals 1/2. On the other one, subtract 5 from both sides, and I get x equals -5. Questions about that? Okay, I'm going to pass out your review. If you are on Zoom, your review is also under week 2 documents, and solutions are attached to that document. This is what the review looks like. The review will be 5 bonus points on your exam. If you complete it, show all your work and turn it in on exam day. Okay, so 5 bonus points on your exam for a completed version of this review. I gave you the answers on the back so you go through all your work. Okay, and this will be due next Friday. And you take your exam number 1 in here. Okay, so remember, no class on Monday. I will see you all on Wednesday. You may want to get started on this so you can ask questions on Wednesday. Okay, for all of y'all on Zoom, you are going, this is due on Friday. It's 5 bonus points on your exam if you complete it, show all your work. You will turn this in on Friday when you take your exam. You have to take your exam face to face, so you can just bring it when you come to take your exam on Friday. Yes. Okay, did you email me about it? Okay. Email me today, and when I get back to my office, I'll open it up for you.
Thank you.
You're welcome.